I'd like to conduct a hypothesis test for a claim about a proportion. On page 402 of our textbook, you find problem number 23 about road rage. In a survey of 2,705 licensed drivers aged 16 and older, 33% of those respondents reported that they make angry gestures while driving, based on data from the Automobile Association of America. Use a 0.05 significance level to test the claim that among licensed drivers aged 16 and older, the percentage who make angry gestures while driving is equal to 35%. Does the conclusion change if the significance level is changed to 0.01? So we're going to have to draw two different conclusions here, one for the significance level of 0.05 and one for the significance level of 0.01. What I'm told in the problem is that the sample size is 2,705. The sample proportion is 33%. In a moment, I will need a number of successes. Well, 33% of 2,705, well, that did not go well. 0.33 times 2,705 is 892.65. Well, that had to be 893, because x over n, x had to be a whole number. It's the number of successes. It's the number of people who apparently make angry gestures while driving. So what really happened is whoever did the study had 893 out of 2,705, and they rounded this to that 33%. And that's why we have to round to the nearest whole number here. Well, we need to write down the original claim in symbols. And the claim here in 23 is the percentage who make angry gestures while driving is equal to 35%. So we can think of that as a proportion that's equal to 0.35. Well, what's true and that's false? The proportion is not 0.35. This is what we call a two-tailed test. There are two different sets of z-scores that would cause us to reject the null hypothesis. We'll be using the p-value method, but always nice to have a visual representation of what's going on. The null hypothesis is always a statement of equality, and the alternate hypothesis is the one of these that does not contain the condition of equality, so it has to be the second one, and this is the case where our original claim actually becomes the null hypothesis. And this other statement is the alternative hypothesis. It's the unique case where that happens. So I have my null and alternate hypotheses. Now I'm ready to calculate a test statistic, a z-score, and a p-value. The probability of getting a sample as extreme as our sample. So hit stat, go over to tests, and this is a one-prop z-test. P naught is the claimed value from the null hypothesis, so 0.35. X is a number of successes, 893. And then I have a sample size of 2,705. I have to click on the symbol from the alternative hypothesis, so this actually says the alternative hypothesis. The proportion is not equal to the claim value in P naught. P naught's 0.35. I'm going to hit calculate. Our test statistic, that z-score, minus 2.1675. That's past two standard deviations below the mean in the distribution of all possible sample means, which means it would be a significantly low value in the distribution, not sample means, sample proportions. And then I have a p-value of 0.03. And if this is our stated significance level, then our p-value is less than our significance level, and we would reject the null hypothesis. In that case, we're literally rejecting the claim here, and we have a flow chart that helps us word a final conclusion, but this is the easiest case. Did the claim contain equality? Well, the claim was equality. Did we reject the null hypothesis? Yes, we did, and that would tell us there is sufficient evidence to warrant rejection of the claim. So that's what we'll write. There is sufficient evidence to warrant rejection of the claim that the percentage is actually, the proportion is 0.35. The percentage is 35%. We have rejected the claim. The author asks us to consider what would happen if instead we use an alpha of 0.01. And this is the interesting case where now our p-value is larger than the significance level, and we would fail to reject the null hypothesis. And so literally, in the last step here, we get the other conclusion: there is not sufficient evidence to warrant rejection of the claim that the percentage is 0.35. So different significance levels can end up with different conclusions. And this is why when you're doing hypothesis testing and statistics in general, you choose a significance level first. You don't do it after you've started collecting data and doing hypothesis tests, because it can affect your results. And then you can be accused of bias.